Hello. Alright, so this video is just going to go over the first two slides from the assignment from Monday. Of course, I got my picture of my teacher there. Someone, I guess, to emulate. There I am. That's him. That's me. I look just like him. Anyway, this question is multiple choice, so I'm going to approach it as though I was taking a multiple choice test. They're asking for how much is dissolved, so how much dissolved means solubility. And so the solubility is going to be based upon the KSP, and the solubility of lead carbonate and lead sulfate in answers A and C have this format: lead times carbonate, or lead times sulfate. Either way, the KSP comes out to be x squared. So I can just take the square root of those answers and I can eliminate answer A right away, because I know in answer A, the square root is going to be somewhere between 2 and 3 times 10 to the minus 14. So it's approximately 2.5, I said 10 to the minus 14, I mean 10 to the minus 7, 10 to the minus 7 molar. And answer C, we take the square root of that and we get 1 times 10 to the minus 4 molar. So automatically I can eliminate answer A. So answer B is in the format of lead times iodide squared. So the solubility is going to be x times 2x quantity squared. So the solubility is equal to 4x cubed. And at this point, I don't even have to worry about dividing by 4. But if I did it, I get approximately 2 times 10 to the minus 9, and then I take the cube root of that. Going to be approximately 1 times 10 to the minus 3. So I'm going to select answer B. Now the next one, solubility of nickel carbonate, and they give you the formula weight, which is funny because you can see that I went and copied a periodic table from the internet and put it there, because apparently I didn't read the question carefully. They already told me what the formula weight is. And they tell me the solubility in mass per 1900 milliliters. What is the KSP? So first of all, KSP for nickel carbonate, again, they're assuming that you know that nickel carbonate dissolves and produces this equilibria, nickel times carbonate. So the KSP for this is nickel times carbonate, and that the solubility is x times x, so we're looking at x squared. Alright, so if I knew the molarity of the nickel carbonate, I know that the solubility of the nickel carbonate is equal to the nickel concentration, which is equal to the carbonate concentration, because there's nothing else in this solution other than nickel carbonate, and we don't have any Le Chatelier's common ion effect shift. So now it's just a matter of doing the stoichiometry here. I can just do a conversion. Starting out with 0.018 grams nickel carbonate, and I want to convert that to moles. So I know that 118.7 grams of nickel carbonate is 1 mole. Divided by 118.7, I get 1.5 times 10 to the minus 4 moles. And do my conversion, 1900 milliliters to liters. Okay, so now I can just come up with the molarity. Substitute in. And let's see if I get what they get. 1.5 exponential negative 4 divided by 1.9. I get 7.9 times 10 to the minus 5. Alright, so now that I know the molarity, I can substitute into KSP. Alright, so KSP is equal to 7.9 times 10 to the minus 5 squared. (6.2 times 10 to the minus 9. So that's my final answer. And hey, oh, well, okay. Well, again, these problems I stole from the Ohio State website, and the difference I'm assuming in the values is because of the way they applied the sig figs. They probably didn't apply the sig figs until the end, so that's why they got 6.4. But there you go. Now, I didn't conclude the last video, so I guess I'm supposed to say something at the end of the video. Hey, this is the end of the video. Thanks a whole lot for watching. Subscribe to my channel and all that stuff.